This presentation is part of a lecture series on the C++ programming language by Michael Adams at the University of Victoria in Victoria, Canada. For those of you who might be interested, a copy of the slides for this lecture series can be downloaded from the website whose URL is given on this slide. In this section, I'm going to walk through several examples of using CMake. In this CMake example, we'd like to build a simple OpenGL application that also makes use of the GLUT library. The code is written in C++, and there are two files in the project. There's our CMakeLists.txt file, which is used for building the code, and there's a single source code file called trivial.cpp. And as we'll see in a moment, the project defines a single executable target called trivial. The contents of the source code file trivial.cpp are as shown on this slide. What the program actually does is not so important from the point of view of this example. What it will do is it will create a graphics window and then fill the graphics window with a particular color. It's not very exciting, but it's a nice simple example that fits on a single slide. The contents of the main CMake build configuration file, CMakeLists.txt, are shown on this slide. So let's walk through the contents of this file in detail. On the first line of this file, we have the CMake minimum required command being invoked, which just specifies the minimum version of CMake that can be used to build the software, and in particular we're specifying a minimum version of 3.1. The next command is the project command, which is used to give a name to the project, which we're calling OpenGL _example, and also the project command is used to specify what languages are used by the project. So here we're specifying the C++ programming language. Then we proceed on to find any required libraries that are used by the software. In this case, we need to find both the OpenGL and GLUT libraries. So to do this, we use the find package command. So first we find the OpenGL library. We specify an option of required here, which says that if the library is not found, this is deemed a fatal error and the build process should just terminate. Next, we find the GLUT library, again specifying the required option. The next few lines from line 9 to line 17 can probably be ignored for most intents and purposes. This is just a workaround on some systems. There's a bug effectively in CMake, and this just works around that bug. Most systems probably don't have this problem, so you can probably leave these lines out and just ignore them. If we continue on, the next thing we need to do is we need to specify some include directories and libraries that we're going to link against. The include directories are specified as GLUT include_dir and OpenGL include_dir. Now these two variables here, GLUT include_dir and OpenGL include_dir, are set when we perform these find package operations up above. So find package OpenGL will set the variable OpenGL include_dir and also set the variable OpenGL libraries. When we do find package GLUT, this will have the side effect of setting the variable GLUT include_dir and GLUT libraries, which we can then use down here. So the first thing we need to do is specify include directories. So we need to make sure that any include directories for the GLUT library get picked up. So we include the include directory for the GLUT library here. We also include the include directory for the OpenGL library here. Then we use the link libraries command to specify any libraries that we need to link against. So we need to link against the GLUT library and the OpenGL library. So we use these variables that were set up above for this purpose. And then lastly, we define a single program target, an executable target, called trivial, and it consists of a single source code file, trivial.cpp. Now I would like to demonstrate using CMake to build the software that we have just been discussing. My current working directory is set to the top level directory of the source tree for the software. So if I list the contents of the directory, you'll see the two files, CMakeLists.txt and trivial.cpp. If I now invoke CMake, and I'll use the shortened form where I specify both the source directory and binary directory explicitly on the command line. So I'm going to specify the binary directory as temp, and the source directory is the current directory. If I run CMake to build the native build files, we get some messages and it tells us the build files have been written to the directory that I specified. Now if I list the binary directory, you'll see that there's a bunch of files that have been created there. In particular, there's a make file, because on the particular system I'm using, the native build tool is make, so the default generator is for make files. Now if I invoke CMake, asking it to run the native build tool, which is make, this is what will happen. It prints out some messages, tells me that it built the target trivial. in other words, the program that I wanted to build. If I now list the contents of the temporary directory, you'll notice that there's a new file that's been created by the build process, this file called trivial, which is the executable program that I can run. If I run it, it just pops up a window. Let me move this over so you can see the whole thing. It just pops up a window and fills it in with the colors light blue. Now I'd like to consider another CMake example. In this particular case, I'd like to build a simple CGAL application. The code is written in C++. In addition to using the CGAL library, it also uses a GMP library. There are two files in this project, our CMakeLists.txt file, used for building the code, as well as orient_test.cpp, which is our single source code file. And as we'll see in a moment, the project defines a single executable target called orient_test. On this slide, we have the contents of the source code file orient_test.cpp. What this particular program does is not so important from the point of view of this example, but just for interest's sake, what it does is it allows, or it reads from standard input triples of points in 2 dimensions, and then performs an orientation test on these points and outputs the result. On this slide, we have the contents of the main CMake build configuration file, CMakeLists.txt. So let's look at the contents of this file in more detail. The first command in the file is CMake minimum required, and this is used to set the minimum version of CMake that can be used to build the software, and in particular we're specifying version 3.1. Then the next command we're invoking is the project command. This is used to give a name to the project and specify what programming languages the project uses. So we're going to call this project CGAL_demo, and the languages that are used is just the C++ programming language, which is indicated by CXX here. Then the next thing we do is we find any libraries that we need to use for this project. In particular, we need to use a CGAL library, so we're going to use the find package command to find this library. We're specifying the required option to say that we really do need this library, and if it can't be found, this is a fatal error and CMake should stop the build process in its tracks. The next 3 lines here, this if and if, what this is doing is it's checking to see if the compiler that we're using is GCC, and if it is, it adds an extra compiler option, which is the f-rounding math option. This is needed for CGAL on some systems. There's a lot of systems where this may not be needed, but just to be safe, probably it's a good idea to add it just to avoid some problems. Then the next thing we do is we specify any extra directories for header files using the include directories command. And to do this, we set the include directory that's used by CGAL using this variable CGAL include_dirs. And this variable here is set by the find package operation up above. When we find the package CGAL, it will have a side effect of setting the value of this variable. Then the next thing we do is we specify any libraries that we need to link with. And there's essentially 2. There's the CGAL library itself, and then the CGAL library uses another library for doing multi-precision arithmetic called GMP. So we need to link against both of these libraries. And these 2 variables, CGAL_library and GMP_libraries, are both set by the find package command up above. Then lastly, we create a program target called orient_test using the add executable command. So the first parameter here is specifying the name of the program target, and the remaining parameter here is specifying the single source code file that is associated with this target. Now I would like to demonstrate using CMake to build the software that we have just been discussing. My current working directory is set to the top level directory of the source tree for the software. So if I list the contents of the directory, you'll see the 2 files that we were discussing, CMakeLists.txt and orient_test.cpp. So first I'm going to invoke CMake to create the build files for the native build tool. And to do this, I'm going to specify both the source and binary directory explicitly on the command line, just to save some typing. When I do this, it prints out some messages telling me what it's done. The build files have been written to the directory that I requested. Now if I list the contents of this directory, you'll notice that it's created a directory called TMP. In other words, it's created the binary directory because it didn't previously exist. If I list the contents of this directory, there's a few files in it. In particular, there's a make file, because on the particular system I'm using, the native build tool is make, and the default generator used by CMake is for make files. If I then invoke CMake to actually build the software, it prints out some messages telling me about what it's doing. And it says that it's built the target orient test, which is the single program that this particular build process generates. If I now list the temp directory, you'll notice that there's a program called orient_test that's appearing here. And I can run this program. I'll give it some numbers as input, basically the points 1, 2, and 3, 4, and 5, 6. There are 3 points in two-dimensional space. And then it will tell me basically that they're collinear as the program works, and yes, it does work. Now I'd like to consider another CMake example. In this example, I'd like to be able to build and install the Hitchhiker's Guide to the Galaxy library, called HG2G for short, and an application that uses this library. The code is written in C++, and the files in this project consist of the files that are listed here, so there's several files. There's our main CMake build file, CMakeLists.txt, and then 2 helper build files, CMakeLists.txt in the app directory and also in the HG2G directory. And as we'll see in a moment, the project has a library target called HG2G, an executable target called answer, and it also provides an option called HG2G_Zaphod, which takes a Boolean value. On this slide, we have the listings of all the source code files for the HG2G library. Of these files, I would like to draw your attention in particular to the file config.hpp.in, in other words, this file here. This file is special in the sense that it is intended to serve as a template for a file that we're going to ask CMake to generate as part of the build process. In particular, we're going to ask CMake to create a new file called config.hpp, but without the .in extension, and create it from the file config.hpp.in, the file that we're looking at here, by doing 2 things. Each CMake variable name enclosed in @ symbols is to be replaced by the value of the corresponding variable, and each number sign CMake directive is to be replaced by either a number sign define directive or a number sign undef directive, depending on whether the CMake variable following the number sign CMake define directive has a value of true or false. To be more concrete, in this particular example, we would like the @ht2g version to be replaced by the value of the CMake variable hg2g_version. Also, we would like the number sign CMake define directive here to be replaced by either number sign define or number sign undef, depending on whether the CMake variable of the same name, hg2g_Zaphod, is true or false. On this slide, we have the listing of the source code file for the application program that is to use the HG2G library. Notice that the source code file includes the header file config.hpp. This is the file that we are going to ask CMake to generate for us as part of the build process. This header file defines the preprocessor symbol HT2G version to be a string containing the version of the HT2G library. Also, this header file may or may not define the HG2G_Zaphod symbol, depending on how the HG2G_Zaphod CMake variable is set during the build process. On this slide, we have the listings for the first 2 of the CMake build files used in this project. First, let's examine the main CMakeList.txt file, which is the one located in the top-level directory of the source tree, in other words, this file here. To begin with, we have the CMake minimum required command, which is specifying the minimum version of CMake that's necessary for building the software, and we're specifying this to be version 3.1. Then we define our project using the project command, so we're going to call the project hg2g_example. We also specify what programming languages are used by this project. In this case, it's just C++, indicated by CXX. Next, we're going to define an option using the option command. So the option command creates a CMake variable to hold a configuration setting that can be specified when CMake is invoked. Often option variables have Boolean values, that is, they're either true or false, and they allow some feature or functionality to either be enabled or disabled. So in this particular case, we're going to create an option variable called hg2g_Zaphod. The next parameter here is just specifying a comment to help the end user to know what is the purpose of this option. It's just controlling, for example, whether or not we define the hg2g_Zaphod variable in our configuration file. And then we have a default setting for this variable. So if the user doesn't specify it, it will be set to false by default. Then we proceed on to set a variable called hg2g version, which is going to be a string that corresponds to the version number for the software. In order to set this variable, we've built it up out of several other variables. We have a major version number, a minor version number, and a patch version number, which have the values 1, 42, and 0 respectively. And what we want to do is concatenate these numbers together with dots in between them. So we want the version string to look like version 1.42.0. So for this purpose, we use the string command to concatenate these variables together with dots in between them. This is the output variable for concatenation. The concat is just saying that we're concatenating these strings. This is the output variable, and then the remaining parameters are the things that are being concatenated. So we're taking the version, major version number, and then dot and the minor version number, and then dot and the patch version number, and stringing them together. If we stopped at this point, though, the build process wouldn't do very much because we're not actually specifying any targets to be built. What we're going to do next is we're going to use the add subdirectory command to say that there's some other CMake build files that we want to now invoke. In other words, some of the other directories have CMakeLists.txt files as well. So there's actually a CMakeLists.txt file in the hd2g directory and also in the app directory. So we're going to use the add subdirectory command to specify there's more CMakeList files that need to be processed. And these commands will cause them to be looked at next. Now let's examine the CMakeList.txt file in the app directory. In other words, the file whose contents is shown here. This CMakeList file is used to build the code for the application program associated with this software. So if we look at what this CMakeList file is doing, first we're invoking the add executable command. This is defining an executable program target called answer. So this is the program that we're trying to build. And the answer.cpp is the source code file that this particular executable program is built from. Then we proceed to use the target link libraries command. This is to specify that the answer target, in other words the program that we're trying to build, this application program, is to use the hd2g library. We need to link against this library. And then lastly, we use the install command so that we can actually install the software after it's built. So this is saying that we want to be able to install a target, because of the word targets here. We want to install a target, which is the answer target. And the place that we'd like to install it, in other words, the destination, is the bin directory. So this is telling CMake where this particular program file should be installed. On this slide, we have the listing for the last of the CMake build files used in this project, namely the CMakeList.txt file in the hd2g directory. This CMakeList file is used to build the hd2g library itself. So if we look at the contents of the CMakeList file, the first thing we do is place the names of the header and source code files for the library into some variables. Just for convenience, it will save some typing below in this file. So hd2g_headers is just the name of the header files for the library. hd2g_sources are the list of the source code files for the library. So there's two header files, answer.hpp and config.hpp, and there's two source code files, answer.cpp and question.cpp. Then we proceed on to use the add library command. This command defines a library target, which is called hd2g, and it specifies what the source code files and header files are for this library, which are listed here. Because we're using variables for these names, we don't have to retype the names of the files here. We can just use the variable names to refer to those lists from above. Then we use the target include directories command. This specifies what include directories are part of the library. So this is going to be the include directory as well as the include directory under the binary directory as well, which is where the config.hpp will be placed. And at this point I probably need to explain the meaning of the CMake current binary dir variable. In other words, this variable here, which appears in several different places like here and here and here. Normally, relative path names in CMakeList files are interpreted relative to the directory currently being processed, which would be somewhere under CMake's top-level source directory. Since the header file config.hpp is generated by CMake, however, it is placed somewhere under the binary directory. Consequently, we need a means by which we can refer to files and directories under the binary directory. For this purpose, CMake provides the variable CMake current binary dir. The variable CMake current binary dir is automatically set by CMake to the binary directory corresponding to the source directory currently being processed. So in the context of this slide, CMake current binary dir, the value of this variable, would be the directory hd2g under the CMake's top-level binary directory. If we continue along, the next thing we do is we use the configure file command. What this does is this actually creates the config.hpp file that I've been talking about. So we specify as the first parameter for this command our template file from which our new file is going to be created. So this is our config.hpp.in file that we looked at earlier. And what CMake is going to do is it's going to take this file, process it as was described earlier, in order to produce this new output file config.hpp, which will be under the binary directory. Then lastly, we want to provide some instructions for how to install the software. We don't want to just be able to build it, but we also like to be able to install it. So we use the install command to specify that there's a target that we'd like to be able to install called ht2g, and the destination directory under which we'd like to install it is the directory lib. So this will allow us to install the ht2g library. We then use the install command to specify the header files and how they're to be installed. So all of the ht2g header files, we want them to be installed in the destination directory include/ht2g. Now I would like to demonstrate using CMake to build the software that we were just discussing. My current working directory is set to the top level directory of the source tree for the software. So if I do a recursive listing of the directory that I'm in, what you'll see are all the files that are associated with this software. So we have our top level CMakeLists.txt file. Under the app directory, we have a CMakeLists.txt file as well as the source code file answer.cpp. Under the ht2g directory, we have two source code files for the actual library, answer and question.cpp, a subdirectory for header files, and then our CMakeList.txt file. In the include directory, we have a subdirectory ht2g, which has two header files stored in it. One of them is our template header file, the one that ends in the .in. So this is not the final header file that's going to be installed, but the template that's going to be used to generate the final one, which will eventually be installed. So what I'm going to do now is I'm going to invoke CMake to generate the build files for the native build tool. And to do this, I'm going to use the -H and -B option to specify the source and binary directories explicitly on the command line. Also, I'm going to set another CMake variable. There's a CMake variable called CMake install prefix. This is a top-level directory under which any installation operations are going to be performed. So I want the installation to be performed, in other words, the software after I built it and I try installing it, I want it to be installed in the directory temp/install. So I'm going to specify this on the command line. I'm not going to specify the ht2g_zaphod option, and if you remember, if I don't specify it, this option defaults to false. So now I'll run CMake, and it's given me some, printed out some messages, told me build files have been written to the particular directory that I requested. If I list the contents of the directory that I'm currently in now, you'll notice that the temp directory has been created. It needed to create this in order to put the build files underneath it. If I list the contents of the temp directory, you'll see that it includes this build subdirectory. And if I list the contents of this directory, you'll see it has a make file. Because the system that I'm using, the native build tool, is make, therefore the default generator on this system for CMake are make files. So this is where my make file has been created. If I continue along, if I print out the value of the config.hpp file that was generated by the build process, remember CMake is generating this file for us from the template file, the one that ends in .in. It's essentially the same name as this, but it ends in .in. If we look at the file that was actually generated, this is what its contents look like. And you'll notice that the ht2g_version has been replaced by the actual version number. And you'll also notice that the number sign CMake define has been replaced by, well, essentially a comment. It's effectively undefining the variable ht2g_zaphod, which is the default behavior. If we don't enable this option, by default it's false, meaning that this preprocessor symbol should be undefined. Now I can actually build the software, so I'll use CMake to do this. I'm going to specify the target to build to be install. So install will automatically build the software first because you can't install it before you build it. So if I specify target of install, it will build the software first and then install it afterward. So if I run this, it prints out some messages and then tells me that it installed the software and so on. At this point, if we list the contents of the temp install directory, this is where I asked CMake to actually install the software. You'll notice that there's a bunch of subdirectories that have been created under there. It created a bin, include, and lib directory. In the bin directory, it put the application program that we built called answer. In the include directory, it placed a subdirectory called hg2g, which in turn includes the files answer.hpp and config.hpp. And then lastly, there's a library directory that was created which has the actual library itself. And of course, I can run the program if I want, the one that's under the bin directory in my install directory. If I do this, it just prints out the messages that we saw in the source code file. It just prints out the version number of the hg2g library and some value that was returned by a function that it called. At this point, I'm going to start over and build the software again from scratch, but this time I'm going to define the hg2g underscore zaphod option to be true rather than let it default to false. So I'm going to run similar commands as what I did before, but what's different here is this time I'm going to specify the value for the hg2g zaphod option. This is an option that's defined in the CMakeLists file, and I'm going to set it to true, which is not the default value. It defaults to false. So if I run this, it generates the native build files, and then I can run, or actually what I'll do first is I'll show you the contents of the config.hpp file that was generated. And in this case, it will look different from before. In this particular case, since we set this hg2g zaphod to true, notice that now hg2g zaphod in our config.hpp file, it's now defined, whereas previously it was undefined. So this has changed from before. Now, of course, I can build the software. So I'll build the software and I'll specify to install it. So I'll specify a target of install. So this will both build and install the software. And then let it do its thing. And then if I run the program, the application program that was installed, this time it's going to print the message hg2g zaphod is defined. If you remember the source code, in the case that this particular preprocessor symbol is defined, the source code for the program will print out this message here, otherwise it doesn't print anything. When we ran the program previously, this line was not output, this line here was not output, because previously the code was compiled with hg2g zaphod not being defined, whereas in this case it is defined.